Yeah. Hello, welcome you to the next session of embedded software testing. This is the unit 3, the last session of this unit, uh, lecture 6. So where we'll go through some of the software metrics and the details and the tools that are used. It's part of the static testing, and this unit is about static analysis, code reviews, and metrics. And we know that in the last session we studied about the metrics, uh, the importance of the metrics. So, what is the basis on which we decide the metrics, especially for the software size? So, we know that we are not deciding the size by the code, not only the code, but the complexity and structure of the code is also important. I mean, the program that is underneath the embedded software. That's how we calculate the metrics. So basically, these metrics are required on a day-to-day basis, or week-on-week basis, or fortnightly basis, or based on the customer inputs. Is to make sure that how well we have done the program testing, how well we are on track, how well the program is progressing. Likewise, so we also have test metrics for life cycle analysis, communicate, evaluating, reporting. So we basically identify, define, then uh, we'll communicate the identified metrics, how it should be entered, how it should be used. Then with the help of that, we will evaluate after capturing the data, verifying the data, and the metrics calculated using some formula on the captured data. Then we will try to report it effectively with various formats, either using the tool or with the help of uh, any documentation that is useful for the stakeholders. Similarly, we will take the feedback from the stakeholders about the complete report of the test metrics. Then we have studied about the software testing metrics types, manual, performance, and automation testing metrics. So manual, what we do is test case productivity, execution productivity, defect, and execution efficiency, severity. All these manual type of metrics we collect. In performance, in terms of execution, summary, scripting, and that especially the performance of the whole environment and the technicality of the tested program will be reported. And some of the important metrics also we had studied, like test case productivity. So total number of raw steps divided by the number of hours that took to develop that will give the steps per hour is what the test case productivity. That means these many steps can be developed per hour. So based on this, this will be used for estimation and the improvement over the period. Similarly, we have defect acceptance in terms of how many defects are valid and what is the total number of defects. That gives a percentage of defect acceptance. Similarly, we have defect rejection, total number of defects that are rejected divided by total number of defects will give a percentage of the rejection ratio. Basically. Similarly, test case execution productivity, number of test cases executed divided by the execution efforts in terms of hours will give the productivity of the execution. So it is more productive if it is 100%. So it is based on the hours. Next one is the efficiency. So efficiency is basically an important metric to determine the efficiency of the testing team in identifying the defects and execution of the software testing. Then we came to defect severity index in terms of how severe those defects are. So this is calculated based on a formula. which is severity index into number of valid defects for that severity divided by total number of valid defects. That will give the severity index, and that can be divided into two parts: severity index for all status defects, severity defects, severity index for open status defects. Similarly, the automation coverage in terms of total number of coverage percentage we will report. If example there are 10 test cases that are automated out of 100 tests, then the coverage is 60%. Sorry, if 60 test cases are automated automation covered, the total number of percentage is 60%. Then there are two important metrics in terms of progress on the embedded software testing, schedule variance and effort variance. So actual effort minus estimated effort divided by estimated efforts into 100 is what effort variance. So this should not be more than 5%. Usually the embedded industry variance should not be more than plus or minus 5%. If it is minus also it is not good. If it is plus also it is not good. At this we have underestimated or we would have overestimated. That shows the index basically on how well the estimation was done and how well the program coped up with those estimation. The next one is being the schedule variance. Here it's for the duration, actual number of days minus estimated number of days divided by estimated number of days into 100 is the percentage. So this also cannot be more than plus or minus 5% of variance, because we cannot afford to have too much of overrun. It is called as two important terms: schedule overrun. That means if it is minus greater than minus 5%, schedule underrun if it is less than 5%. Means schedule is so fast that it is well ahead of what has been estimated. That is what it gives an indication. So that is what is about schedule variance. We have the scope change. So scope change indicates how stable the system is and how much it has got changed from the original scope. Scope can be increased as well as decreased depending on the complexity of the project and how well the program went ahead in terms of development and testing. So that is what we have studied in lecture 5. So today we will continue on the 6, which details about the metrics for automation, automation scripting productivity, automation test execution productivity, automation coverage, cost compression. All this will be automated. So that's sort of a thing we generate. Is typically based on some tools like Excel sheet or any other tool. So we know that common metrics are used: effort variance, schedule variance, scope changes. Okay, so basically for testing we need to deal with the facts in terms of managing what are the facts that we have considered for generating the test metrics, test metrics basically. So for RBT is nothing but requirement based testing. So we need to have a metrics meticulously done in terms of reporting. For example, how many requirements are completely tested without any failures? How many requirements have failures? How many requirements are untested? So these are very important metrics. It is not just enough to report a pass fail count. Failure count, invalid count, not applicable count. There are different sorts of counts which are a result of either a re-execution or fix in the software code or fix in the requirements. It is also important to highlight how many requirements in terms of what are the sort of requirements or the functionality that are executed without any failures. That's what this indicates. And similarly, how many requirements really have failures. That means what is the functionality that is failing. That's what should be indicated using the metrics. And the other one is the are the requirements being uncovered or untested is also another important element of the software metrics which needs to be factored. Basically, this will be a building block for the confidence in terms of how well how solid the testing strategy is and how well the product is. Basically, both are complemented each other, and as a whole, it should be very well supported with this sort of a matrix. So, how do we achieve the competencies? Basically, before release the software to our customers, we will build all these metrics in terms of reporting. So, what are the fixes we have fixed? What are the issues we had, and how well it programs? Basically, he will ask actually, how did you test? What is the strategy? What is the report that you have? All this will be reported. And coverage is also one of the metrics. So coverage will cover the requirements, as I said, in terms of the failures, non-failures, uncovered tests, etc. So basically, more thoroughly tested products will have more confident outputs in terms of metrics. So there is no surprise at large. So definitely coverage is a strict concept because it has multiple dimensions, including code coverage, design coverage, configuration coverage, all these test design techniques coverage, also requirements coverage. More likewise, we have many aspects factored for the reporting. So basically, at the end of testing, we will report in terms of percentage. The goal is to achieve 100% testing requirements or 100% requirement coverage. And in the end, whatever the regression you do, there should not be any failures. So always the percentage should be decreasing. That is what the aim of the metrics report while we are reporting at the end of our test, end of our testing, embedded software testing. Okay, so let's look at some of the examples and the various charts that organization uses in terms of reporting the facts and the software metrics. You can see an example. This is basically being provided by X Black Consulting Services. An example taken. So nicely it is presented in terms of requirements in one column, and the current progress it is showing in terms of coverage. That is, this table talks about requirements coverage by area, currently untested, tested and failed, tested and passed. So altogether, the leftmost column should be 100%. That's what it aims for, right? Okay. So what are the types of requirements or categorization of the requirements that it looks for? One is the functionality. That means requirements in terms of functionality. How are they tested? What are the failures? What are the passes? The next aspects are something like usability. How useful the product is in terms of usability aspects. Then reliability requirements. Then we have performance requirements. Then we have installability requirements. So all this categorization of the requirements, you cannot anymore like uh, performance. Performance already there. Performance again you can subcategorize into timing, speed, memory. Likewise, communication also one of the requirement functionality or requirements category that you can have. For all this you need to report on a total saying that how many are currently being untested, how many are failed, how many are passed. Here in the first one you see functionality, there are 7% of the total number of tests that are not being tested. There is 93% that have been tested, in that 3% are failed, 90% is passed. Similarly the next one, 25% untested, 70% failed, 58% passed. So basically all the facts in terms of requirements it will bring out. So a very nice way of providing the report. This way the metrics can be factored and presented so that the customer and the higher program management will be clear of what is going on in the software testing project. It basically gives a trend. Okay. Next one is again from the same website. Very interesting way of presenting uh, the representation in terms of it's called as a trend chart, also called as a burn down chart. That means how well the program is progressing, where it is going to end. So what is the trend? That is what is happening in terms of various metrics that are going to be that are being captured during the test execution. This is reported using an Excel sheet, or there are several tools that also can be used for reporting the metrics. You can see, so it can be represented anyway, but here example, this figure talks about the bugs open and the resolution trends, how it is being trended for the particular duration. So we know that that end date is here. How are we going to reach it by the current trend? So 9/5/2009 was the last date, and the program is being reported every week starting from 7/19. The test program was started on 7/19, and till 8/30 August 30 this was reported, and it was ending on 9/5. So you can see there are two colored graphs or the dotted lines. The red one being total opened, bug opened, and the green being total resolved. That means how many bugs on the particular day are opened and how many bugs have been closed. See, finally we should aim for the complete bugs closure. That means the green should meet the red. So that is what the trend should end with when we end the testing or end the program. So here there are total number of 110 total bugs are predicted, and start of the program. So there is a 0 bug, and next week, so we have about you have to put a cursor here and move on the right hand side. About 30 bugs are opened, out of which still it is 0. No resolution is there. All the bugs are still open, and During the second week we have about 50 bugs that are opened, and at the same time there are about 10 or 15 bugs have been resolved. Similarly, we have 1, 2, 3, fourth week about 70 bugs have been reported, and about 60, 60 to 70, 50 to 60 bugs resolved. And in the fifth week, we see about 90 to 90 bugs have been opened, and about 80 bugs have been 70, 75 bugs have been closed or resolved. Those bugs are each resolved. And in sixth week, we have about 110 bugs, and bugs are already opened. That means testing is done, but it's not fixed because not all the bugs have been resolved. So about 90 bugs are there still. And in the end, when we reach the milestone or the last date, so we have 110 bugs that are being resolved. This is how the trend set or trend chart will be drawn. You can key in these details using an Excel sheet. Excel sheet we need uh, total number of open bugs, total number of resolved, and we need a date and the upper limit of on the right hand side in terms of total number of bugs. So with the help of that Excel sheet, there are formulas we can apply and draw the chart. Of course, there are different types of charts. It is up to the user or the test manager or the test lead how we can present it so that it is convincible to the customer and the higher program management. Okay, so this is a trend chart, the first one. The next one being the burn down chart. That means this basically talks about the burn down of the program, how I am going to meet on a given deadline. You can see an example here. Take tasks as tests. So there are say hours, something like 250 hours are remaining, and 25 tasks are to be executed. How I am going to reach it? So from the I will start from the left hand side with a total number of allocated hours, and as I progress my hours are going to decrease. Accordingly, the tasks also expected to be reduced so that many tasks we have reached, and when we are left with near 0, our task also should be reducing on the downside. That is what this burn down chart will be prepared. This is also being developed using an Excel sheet. Here you can see on the horizontal axis from day 0 to day 21 how the burn down chart is being projected in terms of day, and on the column side we have two columns, one remaining effort, and on the right hand side we have the number of tasks remaining and completed tasks. So you can add as many as metrics into this. So there are about 3 metrics you can see. One being the green one, which is nothing but the ideal burn down. That means from the beginning, how are you going to burn down towards the end? That means how are you going to complete the program on 21st day? What is the ideal burn down chart should look like? And this one, the orange sort of a color is the completed tasks. So on each given day, or maybe alternate days or a week, there are number of tasks that are going to be completed, and that will be highlighted in this color. So altogether those tasks should accumulate as 25, and the blue ones are remaining efforts. That means we have total allocated 250 hours, and you can see the variation. Finally we are left with almost 0. That should be done well before the day 21, and light blue one is the remaining tasks. So from the day 1 on the 0th day we have all the tasks remaining and we have the full time available. As we progress, the task should reduce as well as the day the remaining time will also getting reduced. That's how the ideal burn down you can see. For example, we take on day 8, so on day 0 250 hours are left and tasks remaining are about 25. So this is how we are going to develop the burn down chart and you see an example day 8 we have completed about how many if I draw on the right hand side 1 2 3 so about 3 tasks plus we already completed on day 5 one task and day 3 one task so 3 plus 4 plus 5 so that means about 5 tasks have been completed on this date day 8 so you can see the total number of tasks from 25 to 20 it has come down. Similarly on day 15 suppose so sorry okay on day 11 uh, 5 plus another 4 9 so total number of tasks should become about 9 this is what you can see 9 minus 25 about 15 tasks are remaining. So meanwhile for executing or doing a task we have also consumed consumed some effort right. So the effort also accordingly has come down. So remaining effort on each day and each reporting day you can see it is getting reduced. It again depends on the resources how much effort they have put whether the resources are on vacation and overall program you can see the up and down are common but at the end of the program we should make sure that we are going to reach the tasks completed as well as the hours well within that the effort hours whatever we are going to consume should be well within the range. Here in this example we should not consume more than 250 hours and we should make sure that when we reach 21 days we are done with 25 tasks. So 3 parameters are important: the duration, the effort and the number of tasks. With these 3 parameters we are going to report the burn down chart. So this is basically being done with the help of several tools or MPP or Microsoft Project Plan or Excel sheet. So developing that and going through the Excel sheet is not scope of the embedded software testing, but typically these parameters are used for reporting the metrics of sample burn down chart. All you have to remember is 2 things we will report it for embedded software testing: trend chart and burn down chart. These are important metrics. This will give a clear picture of where are we heading. Okay. The next one being the metrics capture and tracking tool. What are the tools in general they use? As I said, there are several tools exist in the embedded software industry. That could be Excel sheet, MPP, or any other capturing and tracking tool. Like we have RTRT, which gives a percentage of how much tests have been passed and failed. We have LDRA and we have VectorCast. Likewise, there are many tools. Cantata, likewise. Let's look into some of the common web-based tool, easy to use and maintain. In general, they follow for the embedded applications. Those two are TestLink and Bugzilla. TestLink is for test test management in terms of articulating the test metrics, and Bugzilla is used for defect tracking and defect management purposes. These two tools are common tools in embedded applications and any applications you take. But these tools are not for testing or test execution, but they use for capturing and reporting the metrics, also for tracking. So TestLink is from a sourceforge.net. You can go to that website, you can find out, you can download, you can use. It's an open source. So as long as you are not using for commercial purpose, you are free to use that tool and download and use it. All test cases, test strategy, execution details, all that you can put it. Of course, it has configurations, uh, internal configuration management, and you can use it for plugging into the external configuration also. And you can fine tune the tool as per your need. That is also one of the good feature of that. Maybe in the future session, if time permits, I will try to go through the sample test link and the bug tracking tool Bugzilla. So basically, it's a web-based test management tool. You need a server and all that if you want to install and use that in-house. We'll try to see the basics of test link, how it will capture and track. So it's an illustration of the test link. So for a sample project, test project, that is a basic component in the test link. So test project will have these many parts. Before that, so definition of the test link, what it says about different things that we need to use for the tool. Test case we need. So basically, test case describes a testing task via steps. That means steps can be actions, scenario, and expected results will be part of that. So test cases are the fundamental piece of the test link. Test suite. Hello. So we need to have a test case. We need to have a test suite. I will put a. I will explain you in brief each of these from the definition of the test link tool, test plan, sorry, test project, and user. So these are basic elements of this test link tool, and so with that framework we are going to have it. So this framework we will study. So test case describes a test case through steps. Steps are actions and scenario. Test suite. So basically, test case suite organizes test cases to units. We'll organize multiple test cases as a test suite. It structures the test specification into logical parts. The next one being test plan. So test plan is created when you would like to execute test cases. So test plans can be made up of the test cases from the test project. Test plan includes builds, milestones, and any of the binaries, executable, environment configured items. All this can be part of the test plan. User assignments, test results, all will be part of the test plan. The next one being the test project. Test project is something that will exist till the end in the test link. So till the project is closed, the test project will be created in the test link. Test project will undergo many different versions throughout the testing lifetime because we are going to configure and reconfigure it again and again. As I said, it has an inbuilt version mechanism, so we can use it. Test project includes a test specification with test cases, requirements, and all the keywords. Users within the project have defined roles. So this framework will be assigned to different users. So users will have their own roles, and as per the role, they will key in, use, update, and all that activities they do in the Excel, so that the matrix is collaborated altogether. So next one being the user. What is the user? So each test link user has a role that defines available test link features. Uh, the user can be administration or a normal user. Likewise, depending on the role, we will have a project team using the test link. So this is a test link 1.6 example. What is been told here. So this from the SourceForge. See, test project has a test specification, requirements, test plan, and any other customized fields, and reports on the other hand will be used, and we can import and export the compatible elements into this framework depending on the type of import items, or the we can, if we want to export the existing one, we can do it. Then the users of this framework will be using the test link tool with this framework, and he will play around all these elements like test specification, requirements, test plan, custom fields, and reports, and he can also attach additional items like any scripts part of the test cases he can attach within that. So all this will be part of the framework that will be used in the test link. So that is the importance of matrix capturing tool and matrix tracking tool also. This is basically used for the test matrix, test cases, and test plan and reporting. So the next one being a snapshot of what are the functionality that it has. It's an illustration of the test link example. So what are the different roles and functions that the people they will use the test link as a core team. So the users can be a guest, user can be a test executor, user can be an analyst, user can be a test lead or a administrator. So in the end of this complete testing project, the administrator basically backs up the complete database of the testing. Also is responsible for creating this framework, adding the rights to the users, modifying the contents, and managing the users. All this will be responsibilities of the administrator. And test leader will define the test plan, and he will add test suits to that test plan, and he can create builds, define the ownership, define the priority. All this will be part of the test leader, and also he can write requirements or import requirements from the external entity. And in parallel to test leader, there is a test analyst who can also write and modify the requirements or import the requirements. Further, he can assign test cases to requirements, because test analyst and test leads are very important role people who can decide what test cases need to be used for what sort of a requirements. And test analyst also will help in terms of describing the test results and reporting it. He is also responsible for test specification and assigning the keywords. Test analyst is also can be called as test case writer or test case developer, test engineer. It's up to you how you want to define in your project. Test executor is an independent person. According to this, you can have a same tester executing the tests. So basically, he will execute and describe the test results. And the guest will have some sort of a read access. Who can browse test results and metrics. He can basically analyze, identify the complete project details. So basically, this guest can be customer or PM, project manager, or any other interface people such as QA, quality assurance, quality people. QA also can be part of this test link depending on the project nature. It can be done. So administrator creates the test project. Test lead will import the requirements from any Word document or any tool produced output such as doors from IBM or rectify, and the tester describes the test scenario and context of the test cases, and with the help of a test specification, and he can also, the test lead also can create regression testing aspects, and tester can key in all the test cases, and test lead will create test plan, and you can add build any script execution mechanisms, work instructions, etc. Now the builders have developed the build. The test lead will add those build, and the manager can have a guest role as well to see the results and test cases mapping. Also, the another important aspect of this thing is that traceability. I think that is missing here. It's a very important term that is being used in the embedded software industry. Traceability from design requirements is a must to be reported when we are done with the testing. So there are several steps that are involved for test link usage. Once all these details are keyed in, the execution is carried out and results are logged in and the project is being reported. That's how this tool test link is used. Okay. The next one being Bugzilla. You can see an example. Sorry, this is test link only. The tool snapshot how it looks. You can see whatever we have seen the roles in the previous use case diagram or the functionality overview. Here you can see different elements that are displayed here. On the left hand side you can see the specification, the requirements, keywords, test project management, user administration, custom fields, etc. On the right hand side you can see test execution, test plan contents, test plan management. Each one has its own folders. That folders can be customizable, and these are the basic framework elements that are part of the test link tool. So upon login, these elements can be inspected, modified, or reported or used. So here you can see test link 1.7.4. One admin has logged in. He can view this. He can see this and add or delete whatever it is because he has the administrative activities. So the first step is already he has logged in and created the project. Then the second step, you can see the steps also being specified here as an example. The step 2 will be test project management in terms of creating the test project, editing, deleting the test project, assigning the user roles. Step 3 is the specification. All the test cases will be keyed in, and addition, printing, all that will be done. Step 4 will have a requirements specification document, assigning the requirements to the test cases as step 5. Step 6 will be keywords management in terms of traceability and all that. Step 7, test plan management. So test project management is different than test plan management. Test plan is should be having the user roles and the environment and all that, how builds are managed, all this will be part of this. Step 8 is test plan contents will be keyed in. Step 9 is test cases execution. Step 10 is milestone management or build management or release management. 11 and 12 are executing and reporting the tests. So this is a simple snapshot of a sample program used in test link. Like this, there are several tools, and those tools can be used depending on the project and its complexity that is being applied. So accordingly, the reports can be done. Okay, so the next one being, sorry, it's not a defect, it is the test cases and test management. And the next one being the defect tracker or the defect management. It is also important along with the test cases management to identify the defects, track the defects for closure and report the defects to the appropriate stakeholders. So that is why we use the metrics for capturing the defects and tracking the defects. So it is called defect management. Okay, so the test manager keeps track of following metrics as part of the defect tracker: number of open defects per severity category at a times, number of solved defects in a period per severity category. You know the severity of the defects. Depending on that, he will assign the priority and he will report it, and he will assign for the next fixes. Total number of raised defects, number of retests per defects, how many regression or retests re-execution are done per defect to close it or report it. Total number of retests. So all this will be part of the defect tracker. So test manager basically keep track of this defect tracking. Okay, so defect tracking is done with the help of several tools. Those tools are basically tied up with the test cases tool, primarily because it can be imported, exported with the help of tools such as a test link, and bugs are also can be reported accordingly. So the one a good tool, this is also a open source tool that is called Bugzilla. This can be referred and used from bugzilla.org. This is also basically web based general purpose web tracker where you use a HTML or the web based program to report, update and generate the bugs, and this has a server client link and all that. So with the help of that web based application, this report will be generated to capture the metrics. So that is how Bugzilla being used. It is very similar to the test link. So both can be used in conjunction to generate and report the testing metrics. You can see an example of how beautifully they Bugzilla is nicely uh, nicely reporting tool. So the way it is being used for capturing the metrics, and it is also used for tracking on a day-to-day basis or depending on the type of tracking and reporting mechanism. This is also a web-based general purpose bug tracker. So based on the HTML and the Apache server or whatever server they are using, and this is an open source tool. As long as the commercially it is not being used, it can be used as an open source. And you can see in the next page a snapshot of Bugzilla tool. There are 4 windows that is being shown here on a website that I have referred here, and you can choose the way how you want to report it. There is a type of image how you want to report window is there. Horizontal axis what you want to report, vertical axis what you want to plot. More a line chart being used in this day-to-day progress being used for reporting the number of bugs which are in numbers on the left hand vertical axis. The same report is being displayed reported with the help of a bar chart. You can see on each day how many bugs. So there is a uptrend. So on this day you can see 110 bugs have been reported. On the next day it is 6. On the other day it is 261. Likewise. Similarly, the bugs can be reported using the pie chart, where you can see a pi symbol having it's a slice of resolved in pink color and new bugs in blue color, reopened bugs in yellow, closed in green, and assigned, verified. All this can be reported with the help of Bugzilla tracking tool. So this can be effectively used on a day-to-day basis in terms of reporting. So users or the test leads or the people who wants to report will collect the data from individuals, or individuals also key in as a user in the Bugzilla tool, so that there is no manual intervention much required. Just they have to open the tool and key in the data, and the report will be generated automatically with couple of clicks. So that is what is about the Bugzilla. So with that we come to the end of test metrics capturing. Now we will go through some of the glossary that we were using so far, or we are going to use it. This again from the software test book, embedded software testing book, test book. Test set, collection of test cases, test design technique, a standardized method of deriving test cases from test cases. Test strategy, we know that description of the relative importance of the system parts and quality attributes leading to decisions about desired coverage. Techniques to be applied and resources are to be allocated. Test team, a group of people responsible for executing all the activities described in the test plan. Testing technique, a standard description of how to execute a certain test activity. Test tool, an automated aid that supports one or more test activities such as planning and control, specification, build, initial files and data, test execution and test analysis. Test type, a group of test activities aimed at checking a system on number of related quality characteristics. Test unit, a set of processes, transactions and functions which are tested collectively. Testability review, the detailed evaluation of the testability of a test basis. Test type, did we see this? Okay, test type, test unit, testability we have seen. We can see testing, a process of planning, preparation, execution, analysis aimed at establishing the quality level of a system. Testware, all products produced as a result of a test project is testware. Unit testing, testing of individual software components. White box testing, the test design techniques that derive test cases from internal properties of an object using knowledge of the internal structure of the object. So with that we have completed the unit 3, test metrics, static analysis and code reviews. We will before we end, I will just recap of this unit 3. So what are the unit 3 items that we have covered so far? So we have covered static testing. This is definition, static versus dynamic testing, static analysis, reviews, inspection and the test processes, control coupling and flow, data coupling. Control coupling is also nothing but control flow analysis. Then we had gone through software complexity, the formula using the Maccabee complexity, Maccabee software complexity. Also we took a few examples, and with the help of static analysis tools such as understand for C++ or Mishra, etc. We generated a software complexity and the static analysis reporting parts. Then we had gone through some of the worst case execution analysis aspects and the tools that are used in terms of reporting the WSET, worst case execution time. And we had seen stack analysis, stack overflow, coding standards, common objectives, guidelines, reviews, inspection process, program inspection, program walkthrough and review process, peer the review processes, what are the types of peer reviews, offline, walkthrough, inspection, and test metrics we saw in today's and yesterday's class. Life cycle metrics types, all types of different metric types, and metrics life cycle, test metrics, and reporting it, and we also touch based important metrics details, test case productivity, defect acceptance, defect rejection, test execution productivity, test efficiency, defect severity index, automation coverage, effort variance, schedule variance. So these are some of the important metrics that we had spoken. So with that we come to the end of unit 3. So we will start the next unit, which is nothing but the software integration, in the next session.